Welcome to Simulation and Prototyping. This demonstration is going to walk you through a precedent project and show you how I built this up from a couple of simple ideas and then add complexity as I have a couple of stages of kind of proof of concept that this will work. I'm also doing a project that aligns with our interior design degrees or our interior designers, and with an idea that this project is relevant to some of the things that they're doing, but I think it's relevant in a number of ways for anyone thinking about computational design and thinking about fabrication. So I'll show, let me make a couple changes here. And some of what's happening, this is based on a precedent. This is a light fixture from Lewis Lewis Architects in New York. And I can show you a couple of images of what they have, but basically what I've got set up is a set of lines and curves and a few parameters tied to a few lengths, directions, and bends in the conduit. And so really simple or kind of elegant approach, three-dimensional, and based on the kind of fabrication approach. If anyone has seen an electrician bend conduit, a really simple tool, and using a couple of parameters that can give us these types of lines in space. So how to go about this? Let me save this actually. So that I have it. And I'll start from scratch and walk you through exactly how I kind of approach this and built this. So first, let's look at the precedent quickly. So here's the precedent project from LTL, the Fluff Bakery, and you can see the kind of light fixture hanging in the space here. They have some really beautiful drawings. You can see it's the conduit and the way the conduit gets bent, and then there's a fluorescent fixture attached at the end of that conduit. And so it's kind of branching structure. It's really nice in the way that these move together and then separate. They have a couple of detailed photos here, and it is three-dimensional. And so these angles are moving in X, Y, and Z, and we'll build this up in a second. And then a kind of reflected ceiling photo. I'm starting to see the branching and the way that they're bringing lights to the different parts of the space. And then a couple drawings of these. And so the way that I started, and wanting to start simply, and I want to advocate for starting simply, testing a couple of simple approaches, and then adding complexity from there. I think too often people jump in and try and do too much too quickly, and then they end up having to go back and kind of delete things to simplify it. And so this is a simple sketch that I drew, and what I was thinking about is defining the way that this kind of branch or this kind of line would start with a line drawn in Rhino. So I can select this line. Then simply what happens is that we're going to go a certain distance. We're going to turn. We'll go a certain distance and turn, and then we'll go a distance. And the way that we'll start with this is just to set all of these lengths to be the same, and then we can start to manipulate them. And I'll show you how I thought about developing these kind of curves as it relates to this, and how I bring some control and discipline to the overall way that I would model this within Grasshopper. So let's take a look at this and let's build this from scratch. So I'm going to start a new file. I'm going to do this in inches. I apologize for my international people that are joining. But in the US, we use inches at a kind of furniture and interior scale. I can work in 3D. I've turned all of my colors white, so even to find my origin, I just have to hit 0. And so here's my origin. So what I'd like to do is start with, as I said, let's start with just one line. And so I'll start at the origin. I'm going to make my first line 12 inches long, and I'll just constrain it maybe in the X direction. It doesn't matter which direction I do it, but I've just got this simple line. And the direction does matter. And so I started at the origin and I drew it to the right, and we'll be able to use that directionality as we go forward. So let's start by capturing curve. And so we'll use a curve container, and we'll set one curve, and we'll select it. So now we have it. We can even hide this within Rhino, and we just see the grasshopper representation. And so the next thing that I'd like to do is to be able to work with this line and draw my next line, right? I want to draw a 4-foot line in the same direction. And so to do this, what I'd like to do is to get the endpoints of the line. And this is also a good practice too, to have a container coming out so you know exactly, because you know which is the start and the end. I can hide the endpoints, but now I can see that that endpoint is there. So when I come back later, I can unhide this and I can see exactly which point I'm going to get. It's a little easier than when both of these are exposed. So with that endpoint, now let's draw a line in that same direction for a certain distance. And to do that, I'm going to use the line SDL, start, direction, and length. The start will be at that endpoint. The direction that we'll use will be, we can actually use our line as the direction. And if I zoom in just a bit, we can actually see, or let me change, I'll get rid of that. We can see the default direction there. I want to set this length to 48 inches. Rather than using a slider in this instance, I just like to use the panel. Clean this up a little bit. And so now we can set that to length. So we can see without setting a direction, it's default. I'm going to use my first line as the direction. And now we see we get a 48-inch line that extends from our first line there. We can even hide our endpoint, and now we have that. So, and the way that I wanted to do this was to have that start line and to be able to kind of drive the way that this branches in different directions from there. And so now what I can do is the same thing. I can copy my start and the endpoints from my second curve, and I can expose that endpoint. And so we have our first line, which we see there, our second line here, and then this endpoint. And now this gets to the point where I want to add a bend. I want to have this line go in a certain direction and then change directions. And so to do that, I looked at a couple of different options. The easiest and maybe most elegant option is under points, and to create a points polar. No, sorry, I'm wrong. Yeah, point polar. And this gives us a little bit of control. And so what we want to do is our base plane is going to be at our endpoint. And so let's use this. And I went through a couple of things and ended up making a slight tweak to this in that we have our endpoint. If we just simply set our base plane at the endpoint, and we can see the offset here is 1 inch, and that's where that point is offset in the same direction. I want to actually create an XY plane at that endpoint. So I'll add XY, and I can use that point as the origin for that. And this is going to be okay for now. Well, this is okay for now because I drew my line as an orthogonal line. Let me actually change that because I want to show you. So I'll unhide that line. Let me rotate it in plane. And so now I'm no longer orthogonal. And you can see why I don't want just simply the XY plane, because this polar point, when the XY is set to 0, that's tied to the world XY axis system. What I actually want to do is have my plane oriented to my line. And the way that we can do that is you can say I first set that endpoint to an origin with an XY plane. And then there's a nice tool called align planes. And so what we can do with that is we'll set the plane and then, oh, maybe it's not align planes. It's slightly different. Let's see, planes and adjust plane. No, all of them have such similar align plane, align one single plane. So we drop this in. The plane is the plane, but then we want to align to our line that comes before it. And so when we set that for direction, we hide this, now we see that our plane is here. When we plug in this base plane, now that base plane will move with the line that we have. And so I can unhide this again, rotate it slightly, and now it looks a little bit like a fly swatter or something like that. But at least the plane keeps its orientation in relationship to this line. And what's nice about that, now we have a local level of control to be able to change this XY plane. And so let's make the offset another 48 inches. And so we can see the way that that's offset. And let's set the angle to be 0 is less than 120. We can plug this into XY. We also have to set this to be degrees. So now as we change this, we see there's 90, and then 120 even folds it back on itself slightly. And so that looks good. Let's leave these alone for now. And let's make another line that connects between these. And in this case, we're going to use the line between 2 points. And our start point is going to be this end point. And then the new point that we made will be this end point. And now we have our new line. This is flat, still in our XY plane, but now we have these 2 lines. And we can hide our point here. But as we change this angle, we can see the way that this changes. We can hide our plane. And we can even hide that point. So this looks good. Let's now join our curves. We actually have 3 if we want to incorporate our first curve that was created there. So we can bring from the curve container, we can bring that in. This line here that extended, and we'll hold down Shift and include this. And then our newest line, we'll hold down Shift and include that. We can hide these. Because now we have a new instance of all of them as one continuous curve. And what's coming out of that is a polyline curve. So from that, let's fillet this. That's how I was creating the radius. So we'll fillet this curve, and our radius, let's set to be 12 inches. And when I'm being specific about a dimension, I'm not using a slider. And so that way that will be consistent. Now we see we have our first line, the extension of that line for 48 inches, a radius, and then the 48 inches from there. So let's do this all once more. And to the extent that maybe we can even just copy what we've done. And this is a good point to also mention that the way that we're going to build this is a kind of explicit approach, which is to say that we're going to have 2 bends. Our grasshopper definition will have 2 bends within it. If we wanted to get more complex with this, we could simply put this in a loop, and however many times the loop ran, that would be however many bends end up in the piece as a way of continuing this. And I can maybe do that with a follow-up tutorial. I want to keep this one kind of short and simple. But let's now start with, I think we can take everything after our first line. Copy it. We'll copy it to the right. I'll have to sort out some of these elements that are being dragged over. But we'll take our curve, and now we want to get the end point of our curve. We want to have an origin there, and the direction, and here we can see the importance of this plane. We want this plane aligned with this line. So the direction will come from, let's see, I think we don't want to use the joined or filleted curve. We just want to use this line as our direction. We'll unhide this. We can see now this new plane aligns with this. And so just imagine kind of starting here, going, bending, moving in this direction, bending again, and going again. And so now we have a new point in space, and we can give this a different angle. We have the start and end points of that line. And now our join curves will be, we just simply need 2. We're going to take our filleted curve from before, we'll bring that in, that'll start it. And then our new line here, we'll hold down Shift and add it. And now we end up with, let's hide our plane. We'll hide this line. We'll hide our previously filleted line. And let's see what we have. So we have that filleted line. So we can hide this, and we can hide our point and our other endpoint. So now we're at a point, or sorry, not to keep using the term point. Now we're in a step in the process where we have two sliders, which are our two angles. I like pulling these over to the left so that I have a sense of what's happening. And so our first bend, we can see now that that controls everything after it. I don't like that it disappears when it turns to 0. And then we have our second bend. So we can do a couple of things here too. We can increase this actually to go from -120. And same with this other one. Then we can go -120 to +120 in terms of the angles so that it can actually bend in the opposite direction. And the reason why I'm constraining my slider to 120 is that any greater than 120, it seemed to change the size of the radius of the fillet and seemed to make it smaller. And I didn't like that. So now at least the slider gives me the kind of 120, or it gives me, by constraining, it gives me that option to kind of hold that. So that's working. And so this is nice. If I come back to that simple sketch that I showed you when I started, we have this kind of basic thing working. We have two bends and the way that this kind of moves through. Let's just move to the end for a second and let's set two other things. I do want to add a light fixture to it. And so let me do that. So first of all, let's see, from our line. So we'll go to our last line, which is here. Let's branch off from that and find the endpoints. And let's get a point container. I believe we want the end. We do. So we can hide that. We can even hide this line. So now we have our endpoint here. Let's draw a line in the opposite direction. So we'll do a line SDL. So our start will be at the end. Our direction, well, let's set our length to be 12 inches. And so we can see the way that that defaults. It doesn't have a direction yet. Let's use this line. If we plug in this line, it moves out from there. What we can do is reverse the direction. And so we can bring this, our line that's here, we can reverse the vector and we can use that as a direction. So now our line is moving back in the other direction. And let's just now offset this curve. So the curve we want to offset is our line. And we can see it simply offsets it from there. I'm going to offset it a distance of 2. So we end up with another line parallel to that. We should hide a couple of these. I just want to move my sliders and make sure that that line tracks the way that I want it to. And it does. So let's do one last step in terms of the representation over here on the right. And we'll pipe both of these. So our curve here, our radius will be 0.5. And I'll do a custom preview. give this a swatch and give this just a kind of basic gray. And then we can copy all of this and pull it down for our light fixture. And this radius, I'll give it a radius of 1 and give it a slightly different color. Some of our other elements there. And now we've got a simple representation. And this should work pretty simply. So let's add a little bit more complexity with this. And remember, anything that we've set with a value could become something that changes. So our lengths of 48 inches, those could vary, those could change. We can engage those anywhere we want. And actually, I'd rather not use multiple parameters unless we want to be specific and use multiple parameters. But if we wanted to change them, all of them at once, we can change that here. All right, so this works. Let's look at a couple more things. Let's try some multiple lines, because remember the precedent had many of these. So what I'd like to do with that is we can add multiple curves, but I can actually be much more specific in terms of that. And so what I would like to do is, let's come back over here. Let's draw a couple of these. And so I'll go back to my origin. I'll keep these set to 12. Here's one that's you can see my axis system at the bottom. That's here. I can move that one. So I'll turn it on. Setting them all 12 and setting them on different angles. We can come back and manipulate them. But I also want to do one in the opposite direction, from where I start versus where I end that curve. And they will be specific in terms of the direction of those. So let's see what happens. What I'd like to do is to set a curve container for each one. And so we have 1, 2, we have 4 more. 2, 3, 4. We can set these over here. We could even start to name these. And this gives us a little bit of control in terms of how we might want to group these, what we might want to do with them. So, and what I'd like to do is use a merge. And with the merge, I can plug these in and they'll be fed in here, because as you see, some of these lines go to components that are off in the distance. So let's plug in my first curve into data 1. These are easy enough to change. I can set that. I can set that. And then a simple trick is if we double click on a line, it adds a relay. We can do the relay, and then we can always delete the relay. And then we're not even sure where it goes, but we knew that that plugged in there. So let's add a couple more curves. So we'll set one here. Set this one. And in this setup, we can use these simple 12-inch lines as, let's see, I just want to make sure I did the right ones. So the first one, the second one, the third one, and and the fourth one's there. So now we can plug these in. And this gives us individual control for these. And we can also see what's happening is that all of them are using the same angles. So if we change this, they're all changing uniformly, which may be okay, but that's not really what we want. And so what's nice, or a simple way to kind of build in some of this, is watch what happens. We can see we have 1, 2, 3, 4, 5 of these. Let's make 5 sliders for the first bend. 2, 3, 4, 5. And so one way of prototyping this is to add these. And so what we should end up with is individual control. Nothing changed because we copied the slider and they were all the same. But as we come in and come to the second one, we can move this. The third one. The fourth one. And then the fifth one. And so this would give us a certain level of control. For me, it's a little too explicit, having to control 5 sliders for 5 different lines. I don't necessarily love, but that gives us a certain amount of control. And the reason why I wanted to show this approach is to let you know that here we're starting to match the fact that we have 5 curves that we're starting with. And at some point we're plugging in 5 numbers into here, and it will, Grasshopper will understand and map the first one to the first, right? The first one to the first one, the second to the second. If we delete 2 of these, the last 3 in that group will use the same number. And so it's basically when it gets to the end of the line, it will keep using that one. It'll keep using, it'll basically kind of duplicate that number. So we could add additional values here if we wanted. Another approach, and maybe we'll do this for the second set, I'll undo. So now we have 5 sliders here. Rather than using the slider, what if I make a panel? And so with this panel, why don't I do 10 minus 25, 64 minus 100 plus 80. So now I have a list of numbers. I want to make these multi-line so that it understands them as separate inputs. And here, using the same relay, I can swap out my list for those values. Delete the relay. So if we want to change the last one, we can see the last curve changing in relationship to that. So that's working well. And again, we're slowly and incrementally building additional control and some additional complexity. As I've done, because I like using Grasshopper as a design tool to explore options, I am a fan of random numbers. So and what's nice about the random numbers is that we can control its min and its max, and we can set those, and the random numbers are a nice way to iterate on a lot of different options in a kind of finite way. So using a specific parameter. So let's make 5 random numbers for this first range over here. And the way that we'll go about doing that is we'll start with random. And it asks for a couple of things, a range, a number, and a seed. So the range is a domain. We can use a panel to do this, and let's say -120 to +120. It's as easy as that to make the domain. For number, we need 5. And for the seed value, we could plug in any number, but let's make a slider 1 is less than 250, which gives us a kind of range of options. Within that, if we want even more, we can change this to be floating points. And so I'll have a panel that comes out and we can just take a look at what we get. So now we get 5 numbers between -120 and +120. And as we move the seed value, those numbers become essentially random numbers. So let's plug this in to our first thing here. And that doesn't work. And the reason why it doesn't work is that I need to graft these numbers. Let's see. I need to flatten those. And so now, as we change the random numbers, we can see all of them change. And we can, what's nice about having the panel here is if we get something that we really like, we can grab those numbers, right? We can copy all the contents and we can have a kind of static condition of those that we want. And we can come back and I can do another tutorial on how to capture some of these and create different states of them. But for now, let's set this. It seems to be working nicely. But again, they're all flat. Let's add, you can see we have a Z value here. So let's even clean this up a little bit. These are our X and Y. Let's copy it. And we have 5 numbers. Let's add them to our Z. This just became 3-dimensional now. So at the first bend, it's moving in both X and Y and Z. And so we can change these numbers. The rotation in plan isn't changing, but the rotation in the Z direction is. And we can copy it once more and have a set of random numbers. And again, I know that these were the random numbers that go all the way over to here. But I can use our relay trick again and just feed this into the relay and then delete the relay. So that looks good. Now we can see just our X and Y values changing for our last bend. And we can do this once more and feed this to the Z values of our second bend, of which we haven't done yet. So we do have to drag this all the way over and plug that into the Z. And there's, some weird things can happen when we're using the random numbers. That doesn't look great. But let's just change our seed value and see if it always breaks or if it was just that one specific value. What's pretty amazing to me is that given the range of angles here, it's in 3D space, it's actually really difficult to get any of these to intersect one another or to clash with one another. Okay, so here we have an extreme bend again. Why would that be that way? None of these numbers are too extreme. And so again, if we wanted to have more than a couple bends in these pieces, I might look at a loop to set that up to allow it to keep branching, and we could have many branches from there. So for now, let's see what we have. We've got these. And what I might do is just come back and look at, maybe I'll hide our tubes for a second. So here's our lines. So moving these around, now we have a certain level of control related to defining these. And so we'll turn our conduit back on. My least favorite configuration so far, but easy enough. It also has to do with some of the rotations. And so that way, I like having the ability to control these lines in Rhino. So if we were to be laying something out in a space, that would give us a certain level of control about at least where we initiate these lines in space in the way that it might work. So for the Z values, we might even limit them a little bit. So rather than it being 120 to 120, what if we said minus 60 to positive 60? That'll change our configuration a little bit. We can do the same down here. So we can refine with our limits. We can refine with our sliders. Still getting some of the sharp corners. It seems that if we, well, there's just some values that it doesn't like. But with this, now you should have a basic understanding. Well, again, the most important things for me were to start and show you the simplest of sketches. How do we build this in 2D once? How do we add multiples to that? How do we add some random variability to that as a way to then increase complexity? If we want to have more curves, it's easy enough to add them here, plug them in, and then we could always actually tie into, let's see, one other trick I would add is list length. Let's see if this works. List length gives us 5. And so that way we can set the value of these to be tied to the number of lines that we have. And so if we want to add a 6th line, we don't have to come back and change all of these values for the random numbers. It will automatically add something else for us. So let's add one more line over here. Plug this in. You see that the list length now changes to 6, and we automatically just gained another random number in all of those. And so again, it's easy to add more elements because it's driven by our number of curves. If we want to add more branches, we have to do a couple of things, which would be to kind of copy a chunk of this code and add it. And so in this case, in the kind of grasshopper sense, each branch or each bend exists across here. If we were to do it with a loop, we could just let the loop run a certain number of times, which would add that many bends. And I think that'll be a good second tutorial for me to add to show multiple bends that way. And I'll build off of what we have here, and that'll become a part 2. So I hope this helps. I hope that this gives you a little bit of insight into a few different ways of working. And I hope this helps you on any projects that you might be working on. Feel free to post any questions to the YouTube, and please consider following the channel. And I intend to keep adding more and more tutorials, and I am taking requests as well. So enjoy, have fun. Thanks.